Good evening, all. So, today we are going to start the topic syllogisms. Okay, whatever may be the exam, this topic is going to be very important, and you are obviously going to get questions from this one. So, we will wait up to 6:05 for your friends to join, then we will start the class. Okay, good evening, everyone. If you are able to hear my voice and able to see the screen, please type Y in the comments. We will start the class. Or if you are having any difficulty, please let me know in the comment section. Otherwise, all of you please type Y. We will go on with the class. Okay, good evening, everyone. If you are able to hear my voice. So the topic that we are going to discuss here is syllogisms. So what happened in this topic is, see, you are going to find very bizarre kind of statements. For example, see here. He is saying that all planets are moons, all moons are stars. These kind of scenarios will never occur in the real world. But you have to believe these statements are 100% true and are actually happening in the real world. Then you have to find out whether the conclusions are according to the statements or not. Like, you have to believe the statements are true, then you have to find out whether the conclusions are true or not if the statements are true. That's what we are going to do here. Okay, so let me check the strength once, then we will start. Yeah. So listen, it doesn't matter what is there in the statements. You have to believe those statements are 100% true, even though as bizarre as it can get. For example, say, all books are journals and all diaries are journals. These also not going to happen in the real world. But you have to believe those statements are 100% true, and you have to check whether the conclusions are true or not. So understanding these are somewhat difficult. That's why what we are going to do here is, we are going to draw Venn diagrams. Based on the Venn diagrams, we are going to solve these kind of questions. So listen, if you are unable to understand the Venn diagrams, please let me know in the chat section immediately. Why? Because if you are unable to draw the Venn diagrams, you will never get the answer. So let us see how to draw the Venn diagrams first. Okay, So as you can see here, we are saying all, sometimes you are seeing no, sometimes you are seeing some. So we are going to learn how to draw diagrams for each and every statement. So the first kind of statement here is, see here, if I am saying all A's are B's, in place of A and B you will find different kind of words like planets, moons, phones, chargers, doesn't matter. Irrespective of what you are having in the place of variables A and B, you have to draw the following diagram. All A's are B's. So whatever is inside A, if that is also inside of B, then we are going to call that as all A's are B's. That means whatever is inside of A, the same thing are also going to be inside of B. This is the first way of drawing all A's are B's. Now my question is there any other way to draw the diagram so that you will get the same statement? That means, is there any other way to represent the same statement using any other Venn diagram? See, this is also possible. Let us take the circle is A. On this exact circle, you are having B. Then also all A's will become B's. Like the first one, A is going to be the smaller circle, B is going to be on A. Then you can say all A's are B's. The second one, here whatever A is there, on the exact A we are having B. Then also all A's will become B. So if all A's are B's means this is one diagram and this is one more possibility. Now coming to the second one. Some A's are B's. Some A's are B's means, let us take this is A circle and then this will become your B circle. So this part of A's will become B. So some A's are B's means you have to draw like this. Now is there any other way to represent the same statement using any other Venn diagram? Yes, there is one more here. See here. Let us take this circle is A and this circle is B. Then you can say some A's are B's. Listen, some A's are B's means, see this entire circle is A, the red one. See, obviously some A's are inside B or not? Yes, then you can say some A's are B's. So some A's are B's means this is one possibility and this is another possibility. And the third one here is no A is B. No A is B means you are going to have two different circles, but make sure they are not overlapping with each other. That means make sure they are not touching each other. So these are the three kind of statements we are going to get in this topic. Like first one, all A's are B's, you can draw this one or you can draw second one. Some A's are B's, you can draw second one or this one, fourth one. No A is B, you can write the fifth one. So based on these Venn diagrams, we are going to solve the questions. Okay, now but the problem here is, if you are asking, sir, do we need to draw each and every diagram? No. What we are going to do here is, we are going to first check the basic diagrams. That means this one and this one. If that is becoming true, then only we are going to check the second possibility. Now the question comes, why we need to check two possibilities? Why we can't check just one possibility? Why? Because guys, see, as you can see the questions, in some questions he will say just conclusions. Guys, conclusion means if something is true 100%, that means there is not even 1% chance that is going to get failed, then we are going to call those kind of those statements as conclusions. But there is one more conclusion type, that is this one, possibility. Possibility means there is a chance. There is a chance, but we can't say for sure. See, if there is a chance, we are going to call it as a possibility. If it is going to happen 100%, then we are going to call them as conclusions. I will give you just a simple example. Let us take, all of you have just passed 10th. Now this is MPC and that is, let us take or you can say this is inter and this is diploma. Okay, now what I am saying is, see, some people may join in inter, some people may join in diploma. Now let us take a simple example, or if I say that's going to be very controversial, so we will take some other example. This will be completely going to be controversial. So let us take, you are just completed first year of your BTech you are entering into second year. Now if you know, in second year some of the lateral entries people are going to join with you. Okay, now see, you may have came from inter, but they are going to join with you from diploma in the second year. Now listen carefully. Can I say all second years are from inter? Can I say all second years are from inter? No, I can't say, because there is a chance that lateral entries may join with you. Then this is not a conclusion. But let us take no lateral entry has chosen your college. See, there are some lateral people who want to join in BTech, but let us take none of them has chosen your college. Then all the people are going to be from inter only. Yes, there is a possibility all the people can come from inter, but we can't say for sure. So we are going to say them as possibilities, like there is a chance, but we can't say for sure. Now what is meant by conclusion? Conclusion means something is going to happen for sure. For example, all the people who passed in first year are going to come for second year. Yes, whomever have passed in the first year, they are going to come second year. This is going to happen 100%. That's why we are going to call it as conclusion. But here it is a possibility. Now, how you are going to identify these kind of things in the problem? The first thing here is, while drawing the diagram, if one statement is following all kind of diagrams, like you are getting the answer here, you are getting the answer here, then we are going to call that as conclusion. But let us take you are getting the answer from first one, but you are not getting from the second one. That means there is a possibility, but that is not always true. Then we are going to call it as a possibility. Remember, simple thing. If you are getting the answer from each and every diagram, that is a conclusion. If you are getting the answer in some diagrams and you are not getting the answer in some other diagrams, we are going to call them as possibilities, but not conclusions. Okay, now what we are going to do in the question here is, we are going to take the question, we are going to draw the Venn diagram from the question. Okay, if that Venn diagram is giving you answer for only one Venn diagram, let us take you are drawing 2-3 Venn diagrams, but you are getting answer only from one Venn diagram, but not from the second one. We are not going to call them as conclusion. But let us take you are getting the answer from first one as well as second one, then we are going to call it as a conclusion. Don't worry, even it is seems somewhat confusing. While solving the problem, if you are solving 2-3, you will get better idea. So for now, all of you please just note these three symbols. The first one, all A's or B's means there are two possibilities, this one and this one. Some A's or B's means this one and this one. No A is B means this one. What we are going to do in the problem is, we are going to write only the basic ones first. I told you, conclusion has to be true in each and every diagram. So if the basic diagram is true, then you are going to check the remaining possibilities. But if the basic diagram is failing, that means that is not giving the answer, then you can say that is not a conclusion directly. Remember, if the basic diagram is true, you are going to check remaining diagrams. If the basic diagram is failing, you no need to check the remaining diagrams, you can directly raise that conclusion is not going to follow. Just give it a glance for these three diagrams, then we will continue. Just give me a second, I'm getting a call. Okay guys, I hope this one is clear. Now we are going to solve the questions one by one. Please pay attention. In the meantime, I'll check your comments once, then we will move on. Yeah. Now see, I'm going to tell you one question how to solve. then you have to solve one, then again I will solve one, we will go like that. Okay, now see here, first what you need to do is you have to take the statement, then you have to draw the Venn diagrams based on the given statements. For example, he is saying all plants are moons, so let us take this is the plant circle and all plants has to be moons. Done. We just need to draw the basic diagram. Next one, all moons are stars, so every moon has to be inside star. That's it, we are done with the Venn diagram. Now you have to check the conclusions one by one. All planets are moons and all moons are stars. We are done with the diagram. Now what you need to do here is take the first conclusion. He is saying that all moons are planets. See here, these part of moons are not becoming plants, but he is saying every moon is a plant, which is not true. So you can say that conclusion is not true because it is failing in the basic diagram itself. If something is failing in the basic diagram, you no need to check the remaining diagrams. You can stop the problem there itself. Now second one, all plants are stars. Yes, every plant here is inside star or not, this outer circle. Yes, then second one is true. But wait, you should not mark true immediately. You have to check the remaining diagram because it is satisfying the basic diagram. Now write one more way. So let us take this is one circle. The same circle is plants. On plants I am having moons. All moons I am having stars. Like three circles are overlapping on each other. Now check the second conclusion. All plants are stars. Yes, in this diagram also all plants are stars. So the particular second conclusion is giving you answer in the first diagram as well as second diagram. As it is satisfying all the diagrams, we can say that particular conclusion is true. But listen, let us take there is one scenario where you are getting the answer in first diagram but you are not getting in the second diagram. Then the conclusion is also going to be false, because I told you conclusion means which has to be true 100%. But if you are getting answer in some questions and not in some diagram, means that is not 100% true. So we are not going to call it as a conclusion. So remember, first you are going to draw the basic diagram. If the basic diagram is becoming true, then only you are going to check the second diagram. If you are getting an answer in both the diagrams, then only we are going to mark the conclusion as true. So the answer for this one is only 2 follows. If it is clear, please type yes, otherwise please type repeat. So Y for yes, follow the same pattern. Y for yes, N for no, R for repeat, okay, C for clear. We are going to follow these symbols. So if it is clear, please type Y, otherwise please type R. I will repeat once again, then we will move on to the next problem. All of you please respond fast. Yeah. Now please pay attention. Now listen guys, there is one more thing, that is possibility here. See the word possibility. Possibility means he is asking you whether there is a chance or not. So whenever you see the possibility, what you need to do here is, even if you are getting answer in just one diagram, still that is going to be true. Listen, conclusion means how many diagrams you are writing. You have to get answer in each and every. Oh, somebody is asking to repeat. So okay, we will repeat once again, just wait. Now listen. Yeah, we'll repeat, just wait a sec. Now listen. See, what you need to do here is, whatever the statements you are having here, you need to draw the Venn diagrams for the statements. After drawing the Venn diagrams, what you need to do here is, you have to check whether the conclusions are according to the Venn diagrams or not. So for that, what we are doing here is, we are going to take one by one statements, then we are going to check the conclusions whether they are according to the Venn diagrams or not. So I am going to take the first statement first. Remember, you always have to believe the statements are 100% true. That's why we are taking them as reference point. Now let us take the first statement. He is saying that all plants are moons. So let us take this is the plant circle. He is saying every plant has to be a moon. That means plant has to be inside a moon circle. Done with the first one. Now to the second one. All moons are stars. We are already having moon circle here. So he is saying that every moon has to be a star. That means moon circle is going to be inside star circle. We are done with the Venn diagrams for the statement. Now you have to check the conclusion. What is the first conclusion here? All moons are planets. He is asking that if these statements are true, he is asking whether the conclusions are true or not. That's why I am going to take the first conclusion, then I am going to check. All moons are planets. See, moon is here. That means this entire circle is moon, the green one. But he is saying every moon is a planet, which is not possible because these particular part of moons are not planets according to this diagram. So the first statement is not following the diagram. That's why we are saying this conclusion is wrong. That is not following. Now take the second one. All planets are stars. See here, this entire circle is planet and this entire big circle is star. We know every planet is inside star or not? Yes. So that is following this diagram. That's why we are saying this is true. But what I am saying is conclusion means one has to be true 100%. Just by looking at the diagram, just looking at one diagram, we can't say that is 100% true. That's why we are going to check some more possible ways. So I am going to write one more Venn diagrams where the Venn diagrams is going to follow these statements. That is just one possible way of drawing the diagram. I am going to draw one more way, that is here. All planets are moons. Let us take this is planet circle. Assume on this planet circle I am having moon circle. On this moon circle I am having star circle. So all planets are moons. Yes, all moons are stars. You can draw diagram however you want as long as you are not violating the statements. If you are following the statements, you can draw however you want. Now take what the see, as we are getting the first one is wrong, you need to check this one. But we are saying this one is true, so check only this one. All planets are stars. Yes, here also all planets are inside stars or not? Yes. So this is getting the answer from first one as well as second one. So as you are getting the answer from all possible diagram, you can say this conclusion is true. So that's why I am saying the answer is only 2 follows. But remember, let us take you are getting the answer from first one, but you are not getting from second one. Then the conclusion is not true. The second one is also will become false. So if you are marking something is true means it has to be true in each and every diagram. If you are writing 100 diagrams, that has to be true in all the 100 diagrams. Like that. As the second one I am getting in all the diagrams, that's why I am saying only 2 is true. Is it clear? Type yes if it is clear. If you are still having doubt, type R. I will repeat this problem after solving the second one, so that you can compare what is actually happening there. But if it is clear, please type C or Y. Come on guys, fast. Yeah, let's move on. Now come to this one. There is a small difference between this problem and the previous one. If you observe this word, even though he is saying conclusions, he is adding one more word called possibility. That means he is asking you whether there is a chance or not. Chance means, let us take you got one diagram like this, you got one more diagram like this. You are getting the answer from this one but not from this one. If he is saying that is a conclusion, generally we are going to mark the conclusion as wrong because you are not getting from all of them. But possibility means even if you are getting the answer from just one diagram, you can say the possibility is true. Conclusion means every diagram has to be true. Possibility means just one diagram has to be true. It doesn't matter about the remaining diagrams. Then also you can say this is true. Just wait until problem is over. If you are unable to understand then also, then I will repeat one more time. Now see guys, let us take, I am going to take the statement, I am going to draw the Venn diagrams. So I am saying that all books are journals. So let us take this is book circle, and on this I am having journal circle. Then he is saying all diaries are journals. Every diary is all journal. Now you may get the doubt, sir, why to draw this one? I will draw like this. All books are journals, all diaries are journals. Yes, you can draw, there is nothing wrong. But in order to cancel maximum conclusions, it is better to draw this diagram than this one. So that is called minimum overlapping. Minimum overlapping sense, if it is possible to draw the circles without touching other circles, then draw like that only. Like you can draw like this, you can draw like this, it doesn't matter, that's up to you. But even though if you are drawing this one, then you are going to check this diagram also. That's why That's up to you, however you are drawing the diagram. Okay, so whenever it is possible, try to avoid touching the other circles so you can get the answer very easily. So I am going to take the diagram which I have written first, then you will get better idea. See here. See, all books are journals, all diaries are journals. Done. We are done with the diagram. Now check the conclusions. He is saying all journals are books. See, this is entire journal, but only some journals are going to be inside, but not all the journals. But he is saying all the journals are books, so this one is false. No need to check the remaining diagrams. Now see the second one. Some diaries being books is a possibility. See, if you are checking this diagram, that is actually wrong because there is no connection between diaries and books. Now see, I told you, you can draw the diagram however you want as long as you are not violating the statements. So these are the statements I am going to draw in one more way. See here. All books are journals. Done with the first one. All diaries are journals. This one. Listen, he is saying some diaries are books is a possibility. Yes, some diaries can become books here. That means you are getting the answer from second diagram but not from the first one. Okay, but if the possibility word is not there, you can say this is also wrong. But he is saying a possibility. Possibility means he is asking that is there any chance of getting the answer? Yes, there is a chance when you are having more number of diaries. So you can say this one is true. That means if it is a conclusion, both has to be true. If it is a possibility, just one has to be true. No need to worry about the second one. So as you are getting answer from one diagram, you can say only two follows. Now the question comes, sir, how we know how to draw only two diagrams? How will I know exactly how to increase one circle? That's why you no need to draw these many possible diagrams. The easiest way here is, let's go to the previous one, you'll get better idea. Every time you no need to draw. Okay, before moving on, is it clear up to now why I am saying the possibility is true? If it is true, I will tell you how to identify how many diagrams you are going to get. Please type yes or y. If it is clear, then I will tell you how will you know exactly how to draw that one only. Come on guys, fast. Okay, only one repeat. We'll wait. Yeah. Now see, we'll come back to this one. Don't worry. Whomever is saying to repeat, just wait for 1 second. We'll solve this one and come back. See guys, what you need to do here is all plants are moons. Draw this circle. The basic one. All plants are moons. Then write the all moons are star. All moons are stars. Done. Write the basic diagram only. After, what you need to do here is check the conclusion. What is the first conclusion? All moons are plants. All moons are plants failing here itself. So no need to check the second one. Leave that one. Sorry, no need to check the first one. Leave that one and move on to second. All plants are stars. All plants are inside stars. Yes, this one is true. Now what I want you to do here is, whatever the variables you are having, plants and stars, take these two variables. First I am going to take plants. Assume that, try to expand and compress your circles. In your mind, try to assume that those circles are expanding and compressing. Let us take, I am expanding this circle, the plant circle. Up to what extent I can expand this one? I can expand up to moons only. Why? Because according to statements, plants should be inside moons. So I can expand this green circle up to moon section here. So after maximum expanding also, still I am getting the answer. Why? Even after expanding, all plants are inside stars or not? Yes, I am getting the answer. Then try to compress the circle. After expanding one variable, you are going to have one more variable. What other variable here? Star. Now, as if you compress the star, sorry, if you expand the star, anyway you are going to get the answer. So that's why try to compress the star. If you are compressing the star, this will become smaller and smaller. Up to what extent you can compress? You can up to compress only moons. Why? Because every moon has to be inside a star. After compressing also, are you getting the answer or not? Yes. Even after compressing the star up to here, still all the planets are inside stars, so then also this is true. So if you are getting the answer even after expanding and compression, that will become a conclusion. But if you are getting the answer after expanding but not getting after compression, then that is not a conclusion. What I want to see here is, if you are getting some particular answer even after making the circle bigger and smaller, that is a conclusion. But if you are making the circles bigger and smaller, then the answer is not coming, then that is a wrong conclusion. That's it. You no need to draw several diagrams. Draw one diagram, try to increase the size of the circles. Even after expanding the circles, if you are getting the answer, that is a conclusion. Even if after compressing, if you are getting the answer, that is a conclusion. But if you are getting the answer after expanding but not getting after compression, that is not a conclusion. Conclusion means every time you have to get the answer. It doesn't matter whatever the size of the circle. The only thing you have to keep in mind here is, those has to follow these statements. You can draw, you can expand however you want. The only thing is, those should not violate the given statements. Now let's go back to our problem. You will get better idea. Now what I am going to do is, all books are journals. I am going to take the statement, all books are journals, then all diaries are journals. All diaries are journals. I told you, try to take minimum overlapping. Minimum overlapping in the sense, try to avoid touching other circles. Done. Now check for the conclusions. All journals are books. The first conclusion here is, all journals are books. But if you see here, these journals are not books. That's why it is getting wrong here. So you no need to check the remaining diagrams. But see here, some diaries being books is a possibility. See, if he is saying some diaries are books, you can say wrong. But he is saying possibility. That means he is asking you, are you going to get in at least one diagram? That's why what you need to do is, here the answer is wrong, but we are going to check the remaining diagrams. You no need to draw the remaining diagrams. Take the variables, diaries and books. Take any one of your choice. I am going to take diaries. I told you, you can expand or compress them until as you are following these statements. Yes, I am going to increase the diaries. See, every time I am expanding, the diaries are still inside journals. I am not violating any of the given statements. But if I increase the diaries up to some extent, they are touching the books or not. That means, if you are drawing the different diagrams, yet one diagram, your diaries are going to touch the books. That's why there is a possibility. So as he is also saying possibility, that will become true. But if he is saying conclusion, that means if the possibility word is not there, then this will become wrong. But as the possibility word is there, you can say only two follows. Possibility means just one diagram enough, but conclusion means you have to get in all diagrams. If it is clear now, all of you please type C. We will move on to the next one. C or Y, your choice. Then we will solve few more problems. Simple thing, if you are getting the answer after expanding, compressing, conclusion. If you are not getting after expanding, that is not a conclusion. Okay, if that is clear, all of you please try this question. Guys, if that is clear, please try to answer this one. Guys, give me the answer. Yeah, 1. Let's go. He is saying all puppets are dolls. Let us take this is puppets. Every puppet has to be inside doll. All dolls are toys. Every doll has to be inside toy. That's it. You just need to draw the diagram, then check the conclusions. Some toys are puppets. See here, this entire thing is toys. obviously what will happen, inside some toys are going to be puppets. Yes, it doesn't matter, even if you are expanding this one, still you are going to get some toys inside this one. Even if you are compressing this one, still you are going to get some toys inside puppets. So that one is true. See, even if you are expanding, always some toys are going to be inside puppets. So obviously the first one is true. Next, all toys are puppets. No, these part of toys are not becoming puppets. That is false here. No need to check the remaining diagrams. You can say this one is false. So here answer is only one follows. No, one is true. Some means there will be just, I told you, see, some circle, some can be this possibility also possible. Some means just, is there any chance that a few of the toys will become puppets? Yes, whatever toys inside of here, those will become puppets. So some is true only. Now last one, solve this one. We will go to the next model. Yes, sorry, got it. I will repeat once again. So what I am saying is, the first thing, all lamps are hooks. You need to take the lamp circle, then all lamps are hooks. Then no hook is colored. So you are going to have one more circle hook, one more circle color. The only thing is, while expanding, make sure that hook and color are not overlapping with each other. That's the straight line meaning. Guys, now also you can hear. Okay, so the only thing is, you have to make sure while you are expanding like this, hook and color should not overlap with each other. Why? Because however you are drawing the diagram, make sure you are not violating the statement, because statements are always true. That's why according to the statement, hook and color should not overlap with each other. First one, no lamp is colored. No lamp is colored means he is saying that lamp and color are not touching each other. Yes, why? Because even though if you are expanding lamp, you can come up to here only, you can't come out, because every lamp has to be inside hook. So first one is true, because lamp can't come out and color can't go in. That's why one is true. Second one, some lamps are colored. Some lamps are colored means there has to be some overlapping, but lamp can't come out, hook color can't go in, so there is no chance of getting overlapping. So this one is true. Here answer is only one follows. I hope now you are clear with the basic model, how to draw the diagram. Now we will increase the difficulty level. That is, all of you, I want you to solve this question, statement and conclusion, irrespective of the answers here. Those answers are wrong, don't worry. But irrespective of the answers there, try to solve this one and give me the answer. Forget about the answer here. Okay, forget about what was given there. You are not going to get those answers. Now, try to solve that one and give me the answer. The case of restatement question, try to draw the diagram for all the 4 statements and try to check how many conclusions are true in that. Guys, screen is not clear means that most probably your side issue, because I will check the speed once. So we'll check the speed for you, as he is saying. No guys, we are getting more than 100 Mbps, so there is no chance the screen is not clear. Most probably the problem is from your side. Please check once. Yeah. Remaining people, is the screen clear? Now, I hope you have solved that one. Let us solve it. So the first one is, okay, all cows are dogs. Guys, remember, if you are having any screen clarity issues, just close the YouTube once and join back in live. The screen will get better. Okay. Now he is saying that first one, all cows are dogs. So this is cow. All cows are dogs. Next, some dog are cat. Some dog are cat. Remember, your diagrams may be different than you. That's completely fine. Some dog are cat. All cat are rat. Every cat has to be inside rat. I don't want to write too many circles. That's why I'm making them overlapping at the end. It is not going to change your answer. You can draw the diagram however you want, as long as you are giving the statements, and if you are assuming that the 100 statements are 100% true, and if you are not violating them, you can draw the diagram however you want. That's why, just to avoid so many circles, I am overlapping last two. All cats are rats. Then some rat are lion. Yes, some rat are lion. Done with the diagram. Now you need to check how many conclusions of them are true. Now go here. The first one, some dog or cat. See here, this is the dog circle and this is the cat circle. So this is cat and this is dog. Yes, some dog or cat here is true. Now second one, some dog or cow. See here, this is entire thing is dogs, but these part of dogs are becoming cows or not? Yes. All cat are rat. See, every cat is inside rat only. So that is also true. Some rat are lion. Yes, this is rat and this is lion. Some rat are lion. Everything is true. But if you check here, some of them as marked as wrong. Why? That's what we are going to discuss now. See, by definition, conclusion means you are going to have some gibberish data. Like he is going to say different kind of things. You are going to analyze those things and you are going to deliver some proofs. I mean some truths. We are going to call that as conclusion. Like whatever he is saying, he is going to say something in the statements. You are going to analyze the statements and then you are going to say these are the truths from the statements. But if you observe there, some of the conclusions may be exact replicas of statements. That means without doing any analyzing, you already know those are true. Again you are saying true. That is not the conclusion given by you. That is already there in the problem. As you are not delivering those conclusions, we are going to mark them as wrong. I will explain it in clear words. See here. All cows are dogs. Some dog are cat. All cat are lion. Sorry, rat. Some rat are lion. This was the given data. Now check properly. The first one, some dog or cat. See here, some dog or cat. That is actually true only. But see here, some dog or cat. See here, he is saying some dog or cat. And see here, some dog or cat. That is already there in the statement. That means he already know that is true, because we are going to assume statements are 100% true. He already know that that is true. Again he is asking whether the conclusion is true or not. Here you are not finding anything new. That means you are not going to analyze anything. You are not going to come to any conclusion. You are just saying whatever he is saying again. That's why we are going to call this case as case of restatement. Case of restatement means even though the conclusion is true, if it is already present in the statement, you have to mark that one as wrong. That means if the conclusion is already present in the statement, even though that is true, you have to mark this as wrong one. That's why even though the first one is true, we are going to mark it as wrong. But see here, some dog or cow. He is saying that all cow are dog. He is saying all cows are dogs. From that we are finding out some dogs are cows. Yes, we are finding out. That's why this is a true conclusion. Third one, all cat are rat. Even though all cat are rat true here, that is already there in the statement. That's why we are going to mark it as wrong. The fourth one, some rat or lion, some rat or it is already present, so this is also wrong. So case of restatement means if the conclusion already present in the statement, even though the conclusion is wrong, you have to mark that as wrong one. That is the case of restatement. If it is clear, please type Y, then we will go on to the next problem. If it is clear, please type Y. We will move on to the next one. If you are having any doubt, please let me know. I will repeat once again. Solve this one. All of you please solve this one. When I will repeat, just 1 second. After completion of this problem, I will come back to that one. Okay, now listen. What I am saying in the previous statement is, remaining people, I will explain here only, no need to worry. See, what he is saying is, let us take, I am saying that all A's are B's. You solve this one. In the meantime, I will explain. I am saying all A's are B's, and I am saying that some B's are C's. Then what we are going to do? We are going to draw the circle like this. All A's are B's, then some B's are C's. We are going to draw this one. Let us take the conclusion is this one. Here in the conclusion, the first one is all A are B. That is the first conclusion. Now see here, according to the diagram, the conclusion is true. But the conclusion is already in the statement. Conclusion means you have to find something new. Whatever he is saying, you have to analyze that data. You have to find something new. Then only we are going to call them as conclusions. But whatever the answer you are getting, all A's or B's, that is, he already knows that one. You are not finding anything new. That's why even though it is true, we are going to mark that as wrong. Simply saying, if you are having the conclusion which is already there in the statement, you have to mark that one as a wrong one. That's it. Now listen guys, that is a case of restatement actually. Now let's go to this one. Some hats are caps, some hats are caps, some caps are mats. Done with the diagram. The first one, some caps are hats, some caps are hats, yes. Some mats are caps, some yes. Both are true. And why this is case of, sorry, why we are not considering case of restatement here is, see here, hats, caps. He is saying some hats are caps. We are finding out some caps are hats. That's why this is true one. This is not case of restatement. Case of restatement means if you are having AB, that exactly you are going to have AB in the conclusion. Okay. So case of restatement means you have to have exact copy and paste. But this is not exact copy and paste. He is saying something, we are finding something else. That's why that is true. Okay. Now we are going to solve one more problem. Let's go back. Solve this one and give me the answer. Solve this one. This is going to be very difficult compared to any other problem, but solve this one, you will get better understanding of what we are doing here. This is the important one in the entire topic, so try to solve that one. Okay, guys, listen. If if something has to be conclusion, you have to get the answer in each and every diagram. Now see what is happening here. Some bottles are pencils. Pay very attention here. Some bottles are pencils. Now some pencils are glasses. Some pencils are glasses. Done with the diagram. But I told you conclusion means you have to get the answer in each and every diagram. That is, see here. No glass is bottle. See, glass is here, bottle is here. That seems true here. Like both are not touching, so you may think that is true. But I told you, you can draw diagrams in different ways. Now, try to expand the bottle and glass circles. If I expand the bottle and glass, some bottles are pencils, some pencils are glasses. Some can be anything. Let us take, I am having 100 apples here. If I am having 100 apples, if I take 2, I can say I have taken some apples. Even if I take 98, I can also say I have taken some apples. Some can be the smallest possible to max number. Both are possible. So, here see, he is saying that some bottles are pencils. Now I am taking more bottles as pencils. And he is saying that some pencils are glasses. Yes, this time I am taking more pencils. I am not doing anything. I am just simply expanding the circles. I told you, you have to get the answer even after expanding. So here if you are expanding, no glass is bottle is becoming false here. So if you are getting an answer in one diagram but not in the other, then this is not a conclusion. Okay. Now go to the second one. You have to get the answer in each and every diagram. Now let's go to the second. Some bottles are glasses. See, some bottles are glasses failing here itself. Some means they has to be overlapping. So you no need to even check the other diagrams. That is also false. So if you know up to this step, you should get the answer as both not follow. Like 1 also not going to follow, 2 also not going to follow. You have to get the answer as 1 and 2 both fails if you know only up to this step. If it is clear till now, all of you please type Y. I will tell you what to do in these scenarios. There is one more case called like complementary statements. We are going to check that one now. If it is clear up to now, please type Y. Good. Now see, if it is any other problem, you can leave the problem here itself. You can simply write 1 is not going to follow and 2 is not going to follow. That's enough. But something called complementary statement concept is there. Complementary statements means you are going to find same kind of variables. Observe here. In glass, bottle, bottle, glass. Whatever the variables you are having in the first conclusion, the same variables are going to be there in the second conclusion. If you are having like that, you have to check them together also. For example, I am asking you to find out relation between two numbers 1 and 2. So I am saying that 1 is some number, or you can say A and B. I am asking you to find out relation between A and B. In first conclusion, I am saying A is greater than or equal to B. In the second conclusion, I am saying A is less than B. If you are checking separately, both of them are false. Like you can take different combinations like 1, 3. If you are taking 1 and 3, this will become true, but this will become false. But if I take 4 and 4, this will become true, this will become false. It's like you can't always say only one of them is true. But there is a chance that if you are combining both of them, those will form all the universal conditions. Separately, both of them are going to be wrong, but together they are going to form all universal conditions. In that case, you have to check the answer either. I will explain if you don't understand that one. The simple thing here is, you are going to get the answer wrong in both of them. If you are getting wrong in both of them, then you have to check whether you are having same variables or not. Same variables or not. If you are having same variables, you have to check together also. Together means you have to draw both the possible diagrams. Like this is one possible diagram, this is one possible diagram. Then check here, no glass is bottle. No glass is bottle is true here, but the same thing is false here. Some bottles are glasses. That is false here, but that is true here. If you observe there, you are going to get exact complement. Like whatever true in first diagram, that will become false in the second diagram. Whatever false in the first diagram, that will become true in the second diagram. If you are getting answers like this, then you have to choose the option as either 1 or 2. That means you can't say for sure the first one is answer or the second one, but one of them is going to be always your answer. Like you can't say whether exactly the first one is following or exactly the second one is following, but whatever may be the scenario, one of them is always going to be your answer. Just take this example. I am having some bottles which are made up of glass. This is also glass. Now let us take, I am having one more bottle which is made up of plastic. Now see, randomly you are picking one bottle. Let us take, I am picking plastic bottle. If I pick plastic bottle, that is not going to come under glass, so this will become true. If I pick the steel bottle is also not gonna come out of glass, so this will become true. But if I take the glass bottle, that will come here. So it doesn't matter whatever the bottle you are picking, one of them is always going to be your answer. You can't say all the bottles are glass, you can't say all the glass are not made up of glass. Some can be made up of glass, some may not be made up of glass, but one of them is always going to be your answer. If it is made up of any other material, this will become true. But if it is made up of glass, the second one become true, but one of them is always going to be your answer. So if you are coming across these kind of conclusions, you always have to choose your answer as either 1 or 2. If you don't understand, simply what you can do is draw both the diagrams. Whatever coming true in this one will become fail here, whatever failing here, that will become true here. Then if you are coming like that complementary, then you have to choose the answer as either 1 or 2. So what you need to do here is, first you have to check both of them separately. Both of them are going to fail. If they are failing, then only you have to check whether you are having any common variables. If you are having same common variables, you have to check them together also. Like draw all the possible diagrams, then you have to check you are getting complementary answers or not. That's it. So here the answer is either 1 or 2. Now if it is clear, type Y. I will tell you one more scenario. See, separately both of them are going to be wrong, but if you are combining them, one of them is always going to be your answer. All of you, if it is clear, please type Y. Now, the thing is, every time you no need to check whether you are having complementary statements or not. There is some shortcut here. See, the first one is you are going to find same variables, the first one and the second one. Then you have to check this one. In one statement, in one conclusion you are going to have some. In the second one you are going to have no. Like some A's are B's, no A is B, like that. If you are having one in some, one in no, then 90% of the case you are going to get the answer as either 1 or 2. Second one, in one conclusion you are going to have all, and like you are going to have the same variables A B. In one conclusion you are going to have all, in second conclusion some not. Like all A's are B's, some A's are not B's. Or you may get some and some not also. Some A's are B's, some A's are not B's. So if you are having any of those combinations, like some no, all some not, some not, okay, and if you are having same variables like A B in first one, A B in second one, in one conclusion you are going to have some, in the other you are going to have no. In one you are going to have all, in the other you are going to have some not. In one you are going to have some, other you are going to have some not. But the variables games are going to be same. Then in 90% of the cases you are going to get the answer as either 1 or 2. Okay. Next we will discuss about those 10% cases. Why I am saying only 90%? Why not 100%? That's what we are going to see here. See this problem. The hook one, I told the answer as only one follows, but if you check the conclusions, here no, some, lamp, color, one you are having no, one you are having some, but I am saying answer is only one follows. This should be answer either 1 or 2. Why you are getting one follows? Why? Because see here, according to all lamps are hooks, no hook is colored. See this line, the no line. If you are having at least one no in the statement, if you are having the word no is not there, let us take the word is no is not there, then without solving the problem you can say the answer is either 1 or 2. But if you are having at least one no in the statements, like any of the statements, even if you are having 5 statements, even if you find one no, you have to do the problem, then you have to mark. But if you are having not any no here, let us take the no is not there, then without solving the problem you can say the answer is either 1 or 2. But as the problem contains no in the statements, you have to solve and then you have to mark the answer. So don't simply by heart that just you are having a common variables, you are going to get the answer as either 1 or 2. That is not true. That is true as long as there is no in the statement. If you are having at least one no in the statement, you have to solve it, then you have to mark it. But if you are having any no here, then no need to solve the problem. You can choose the answer as either 1 or 2. You will get the idea. We will solve one last problem, then we will wind up. I want everyone to solve this one, so you will get better idea. All of you solve this problem. The last one. Once we are done with this one, we will move on. Okay, let's solve this one. Some boxes are trees. Some boxes are trees. Some trees are horses. Some trees are horses. All horses are fruits. All horses are fruits. Done. What is the first conclusion? Some fruits are boxes. See, fruit is here, box is here. It is failing here itself. No need to check the diagram. So this one is wrong. Some fruits are trees. See, fruit is here and tree is here. How much bigger you are drawing this one? Again, some of the fruits are always going to be trees. So second one is true. Because how much bigger or smaller you are making, that is always going to be the true one. Next, some horses are boxes. Horse is here, box is here. So both are not overlapping, but he is saying some. So this is also wrong. The last one, no fruit is box. See, fruit is here, box is here. That may seems right, but if you are increasing the box's size, okay, like you are going to get the circle like this: box, trees, horses, horses on a bone, you are going to get fruits. If I make the circle somewhat bigger, I am not getting this no fruit is box, so this is also false. So if you are checking the bus diagram, you are going to get only 2 follows. But wait, once you got done with the diagram, you have to check for complementary statements. Complementary statements means same variables. Same variables means, see here, fruit, box, fruit, box. You are having same variables. In one you are having some, one you are having no. So if you are having, see here, there is no in the statement. If there is no, you can directly say the answer is either 1 or 4. But we want to check them using our problem also. Listen, if you are having any no statement here, you have to do the problem and check. But as no is there, you can directly say the answer is either 1 or 4. But still I want to check whether either 1 or 4 is true or not. That's why I am doing the problem. So how you are going to do the complementary statements? Take the first one. Some fruits are boxes. Some fruits are boxes is wrong here, but that is true here. No fruit is box. That is true here, but that is false here. So you are getting complementary answers. Whenever you are getting complementary answers, you have to choose the answer as either 1, sorry, here not 2, this is actually 4, because we are checking the fourth conclusion. So answer is either 1 or 4. So according to the complementary statements, answer should be either 1 or 4. but originally 2 also should be true. So the answer should be along with 2 either 1 or 4 should be your answer. So see here, see either 1 or 4 and 2 follows. So your answer is going to be option C. So first you are going to check separately. Once you are done with the problem, then go for complementary statements and check for them. If you are getting complementary answers, then go for either 1 or 2. If not, just simply write those are not going to follow. First check separately, then only check complementary statements. If you are having common variables like fruit box, fruit box. If it is clear, type yes, all of you. Check them separately, then check after combining them. That's it. Please write one last time clear, then we'll wind up. Now my suggestion here is, after completion of the class, please go to any random website, like write this spelling. Syllogism. Just go to Google and type this spelling, syllogisms. After typing, just search for problems in Google search. Okay, you will find different kind of links. Open any random link of your choice, take any random problem and try to solve this one using our Venn diagrams. If you are not getting the answer or if you are unable to understand what is there, just leave me a mail or type in the Telegram group here. In this Telegram group, you can also post questions. I will solve the question and send it to you. Ashok Kumar Bandi students. Go to Google, type the spelling, try to solve any, choose any random link and choose any random problem. If you are getting the answer, that's completely fine. But if you are not getting the answer, take the screenshot and post in the above Telegram group. I will solve it and send it to you. Okay guys, that's it for today's class. You can leave. Chandana, what's your question? Can you ask once? If anybody having any doubt, you can ask. I will wait for next 2 to 3 minutes. If you are not having any questions, you can leave the class. Thank you. Waiting for your answer. I'm waiting for your question. If you want me to repeat any problem, please type the model number, like the basic one where we are going to draw just diagram, second case of restatement, and the third one, the last one. Okay. Okay, see, he is saying that first draw the diagrams as it is how you are doing in the normal diagrams. So like some boxes are trees. So here I am going to take some boxes. Some boxes are trees. Some trees are horses. Some trees are horses. All horses are fruits. That's the basic diagram. Okay, next, once you are done with the diagram, check the conclusions one by one and mark whatever the answer you are getting first. Some fruits are boxes. See here, this is the fruit circle, but this is the box circle. Some means there should be some overlapping like this, but there is no overlapping. That's why I am saying first one is false. You have to go the conclusions one by one first. Next, some fruits are boxes. See here, fruit circle is here. Sorry, some fruits are trees. Tree circle is here. See here, this is the tree circle and this is the fruit circle. Both of them are overlapping or not? Even if you are expanding the size of trees or fruits, still you are going to get the answer. That's why second one is for sure true. Okay, let's go to the third one. Some horses are boxes. See, horses, boxes. Both are not overlapping, but C is saying overlapping. So that is also false. Done. The last and final one. No fruit is box. No fruit is box. This is fruit. Sorry. No fruit is box. Seems right here. But the problem here is, I told you, conclusion means you have to get the answer even after expanding. Let us take, you are expanding this box circle like this. Then some boxes are becoming fruits or not. That means if you are expanding, you are not going to get the answer. That is why this is also false. We are done with almost the problem. If you are not having any complementary statements, you can stop it here. If you are not having any complementary statements, you can stop it here and you can say only two follows. But the problem here is, before stopping the problem, you have to check for complementary statements. See here, complementary statement, you have to have same variables. See, fruit, box, fruit, box. There are no statements which are having the same words, but these are the only two. That's why we are going to call them as complementary statements. Whenever you got complementary statements, the first thing you need to check here is, do you have any no in the statements? If you are not having any no, you can directly write the answer as either 1 or 4. But if you are having any at least one no, then you have to solve the problem, then only you have to mark the answer. So by looking at here, I can directly say there is no no in the statements. I don't have any no in the statements. That's why I can say the answer is either 1 or 4. So either 1 or 4 for complementary statements, and I know that 2 is also true. That's why I am saying the answer is the third one. But in the exam, you may not get this thought. That's why whenever you find the complementary statements, write different kind of diagrams. The first diagram here is some boxes are trees. I am expanding this one because I got the wrong answer when I expand this box. That's why I am writing the box is bigger. So some boxes are trees, some trees are horses, all horses are fruits. Now you need to check only statement 1 and 4. See here, some fruits are boxes, which is false here, which is true here. Then no fruit is box, which is true here, but which is false here. If you are getting like this, whichever is true, that will become false, whichever is false, that will become true. Then you have to mark the answer as either 1, this is fourth one, either 1 or 4. That's it. So if you are not getting, let us take, you are not getting complementary, like you are getting 1 true, 1 also true here, then you should not mark them as complementary. Complementary means you have to get different answers, false true, true false. Then you have to choose either 1 or 4. So anyway, I am getting like this only. That's why I am saying answer is either 1 or 4. So 2 is always true plus either 1 or 4. So the answer is option C. That's it. Watch the problem once again. If you are unable to understand, then leave me a mail or message. Then I'll explain once again. Okay. That's it, guys. Thank you.